Complex number, that's the topic for the discussion. So we know about the real number. In real number you have positive real number, negative real number, zero. We have rational number, irrational number, right? Like square root of 2, square root of 2. Okay, so all these numbers are real numbers. So when we try to solve problem like this, for example, let's say x minus 5 equals 0, for what value of x this equation is true, then you can say that, hey, for x equal 5, this statement is true because x equal to 5 makes 5 minus 5 0. But let's try to solve this one, x squared plus 1 equals 0. So meaning for what value of x, square of that number plus 1 would be 0. So if we try to solve this, we get x squared equal negative 1. And we know for any real number means you just have three different categories: 0, positive, or negative, right? If you take 0 and square it, it would be 0 square is 0. If you take a positive number and square it, it would be positive. If you take negative number and square it, it would be negative. But there is no real number whose square is negative 1. So there is no solution for this equation in real number system. So we need, if there is anything else, any other system, we need to know about that. And that's the reason we're going to discuss about this complex number, which is, more than the real numbers. And then we try to do computation between the complex numbers. So first of all, so what are the complex numbers? Some function have zeros that are not real number, and then to find the zeros of that type of function we use complex number system. When you try to plot the graph, let's say you have a graph, and let's say the graph is, let's say this is the graph. Okay, if you look at this graph, you can see that the graph is not intersecting with the x-axis. That means this graph doesn't have x-intercept. This graph doesn't have a real zero, no real zero, but it might have a zero which is not in the real number system. It might have complex zero. Okay, so let's introduce a notation here. I stands for imaginary. So what is I? How do we define I? I is equal to square root of negative 1. What does that mean? If you square both sides, it will give you I square equal negative 1. So if you remember the problem I was talking about, x square plus 1 equals 0. So for what value of x this becomes 0? If we try to solve this, you see that for square of x there is a negative 1. So we don't know the solution for this equation in real number system. That's why we create a notation I, and we say that, hey, the solution of this equation is possible if you have this system where you have the value of I is square root of negative 1, or I square is negative 1. And this is an imaginary system. That's why it's called imaginary number. Now, using that notation I, we're going to create a system called complex number system. And how do you do that? We're going to form a number a plus bi form, where a and b, both of them are real number, and I, what is the I? We will just define the I is square root of negative 1, or square of the I is negative 1. Okay, so square of the I is negative 1. So complex number, We can always write down complex number in this form. For example, 3 plus 5i. That's one of the example. Let's say 5 minus 3i. That's another example. Here you can see there are real numbers and there is I. So whenever you are writing a number in this form, that's called complex number. Okay, there are two different parts in the complex number, as you can see here, a plus bi. The first part without I is called real part, and then second part with the I is called imaginary part. If you have two complex number, you can add and subtract between them. You just have to add the real part separately and then imaginary part separately. Meaning, for example, let's say you have 3 plus 2i, that's the one number, and you have 2 plus 7i. If you try to add these two number, then you have to add 3 and 2, which is the real part, and you have to add the imaginary part, which is 2 plus 7, which is 9i. So 3 plus 2 is 5 plus 9i. So whenever we add or subtract two complex number, we have to take care of the real parts and imaginary parts separately. Multiplication, if you try to multiply two real number, this is true for the real number, but if you try to multiply two imaginary number or two complex number, then that might not be true. So this relation of multiplication, which is true in real number system, this is not true in complex number. For example, let's say if you multiply square root of -1 and square root of -1, according to this number system, it's supposed to be square root of +1, but that's not the case in imaginary number, because this is I and this is also I. So if you multiply this to I, it is -1. So this relation is not true in complex number. So you have to be careful. So when you are playing with the I, make sure that when you raise the power of I, so I stands for square root of -1. When you take I square, this is -1, which is a real number. If you take I cube, which is I square times I, which is -I. So when you raise the power of I, you have to be careful that it could be either -1 or -I, or if you keep going up, let's say I to the power 4, it will be -1 times -1, which is +1. So these are the different options you are going to get. The power of I cycles are either I, -1, -I, and +1. Conjugates of a complex number. Let's say you have a complex number a plus bi. The conjugate of this complex number is you just change the sign of the imaginary part, and that is conjugate. So for a plus bi, the conjugate is a minus bi. For a minus bi, the conjugate is a plus bi. So some examples: for -3 plus 7i, the conjugate is -3 -7i. The good thing about the conjugate is whenever you multiply the two complex number and its conjugate, then that multiplication always gives you real number. So when you multiply this number, you are going to end up with the real number. That's why conjugates are important. So let's look at some examples from your homework problem. Express in terms of I. So what is the square root of -6? Let's say you want to express square root of -6 in terms of I. We can divide that into two different pieces. So let's say here square root of -6 can be written as square root of 6 times -1. So that is square root of 6 times square root of -1. square root of -1. So square root of 6 is a real number, and square root of -1 is I. So it's a I that is for an square root of -1. Okay, so and then square root of 6. So the answer for this one is, if you want to write down in this form, a is supposed to be 0, you don't have to write down the 0, and b is square root of 6, and there is a I. Okay, how do you add this to? Add the real part, which is -2 plus 6 is -4, and add the coefficient of imaginary part, where 4 plus 5 is 9, and then I is already there. What happened? What did I do wrong? -2 plus 6 is +4. Sorry about that. It's +4. That was the mistake I did. Let's go subtract one complex number from another one. You do the subtraction between the real parts. So 14 minus 8 is 6. And 5i minus 2i is +3i. So you have to do the simplification between the real part and then imaginary part separately. How do you multiply this to? Square root of -25 and square root of -16. So the multiplication is, remember, square root of -25 is actually square root of -25 is actually square root of 25 and then square root of -1. This is 5 and this is I. Okay, square root of -16 is similarly, it's a square root of 16 and square root of -1. One more time, this is 4 and this is I. So whenever you are multiplying this two number, you are multiplying 5 times 4, which is 20, and I times I, which is I square. But what is I square? I square is -1. So the answer is supposed to be -20. -20. It's a product. You are multiplying two complex number, -2 plus 6i times -2 plus 6i. So you can just FOIL it. -2 times -2 is +4. -2 times this one is -12i. My pen is not working properly. Positive 6i times -2i is -12i. Positive 6i times positive 6i is positive 36i square. Okay, so this is 4 and then minus -12, and -12 is -24i, and 36i square means it's a -36 because I square is negative. So -36 and 4 is -32 minus 24i. So this is -32 minus 24i. Okay, what was the last question? Okay, simplify. How do you simplify? To simplify this thing, you can multiply. We don't want the complex number on the bottom part. We want to express this as a plus bi form. So whenever you have situation like this, multiply the top part and bottom part by its conjugate. So what happens is the conjugate of 5 plus 11i is 5 minus 11i. So when you multiply this by using the get a the foiling. 5 times 5 is 25. Okay, my pen is not working properly. Okay, so 5 plus 11i times 5 minus 11i. So when you multiply this, 5 times 5 is 25, and by using the foiling it would be 121. 11 times 11 is 121 I square. Square of the first thing minus the square of the second thing. So that would be 25 minus I square means negative 1. So negative times negative is positive 121. So which is 176. So conjugate of this is 176, which is positive number. So whenever we multiply 5 over 5 plus 11 I by its conjugate on the top and on the bottom, on the bottom you already have this 176 because you are multiplying the complex number with its conjugate, and on the top it's a 5 times 5 is 25 minus 5 times 11 is 55 I. Now you can individually divide by 176, so it will be 25 divided by 176 minus 55 divided by 176 I. So that is your answer. Simplify the fraction 25 over 176. Do you see any common factor here? 5? No. Here 5 and 11. Yes, 11 times 5 is 55. 11 times 1, 11 times 6. So it's a 5 over 16. You can simplify this part. So the answer for this one is 25 divided by 176. There is no common factor, so no simplification. 5 over 16 I. So that is the simplified version. What happened? What did I do wrong here? Let me go back here. 5 over 16, 25 over 176. If I multiply this two, it's a 25 minus 121 I square. I square is negative 1, so it's 121 plus 25. Oh, my addition is wrong. It's supposed to be 146, not 176. 146. 146. Okay, so there is no common factor still, and there is no common factor here as well. So it would be 55 over 146. 146, not 176. My addition was wrong, so even on the second part it's 55 over 146. Okay, excellent. So that's for this section.